All right, welcome back. Hope you guys are having as much fun as I am. Making a ton of videos is always a blast. So, we're starting a new chapter. We're going to talk about different types of polynomial functions. Today we're going to focus on quadratics, which is a review. So hopefully everybody's just going to get this and think it's super easy. So you got the definition of the polynomial up there. So remember that polynomials are defined by their degree. There was an even degree and an odd degree. We just look for the biggest power of x when it's in standard form, and that tells us the degree. Or if it's in factored form, we add up the number of x's. So if there is no x, it has a degree of 0, and that's called a constant function. Remember back to horizontal lines? Fun stuff. All right, so I'm going to scroll this down a little bit. See, I actually came to school to do this because I tried writing on one of those little tablets, and it was like you couldn't even read it. So I have to use the smartboard to write on so you guys can actually understand what I'm trying to write down. So you look at that mx plus b, that's a linear equation. So what the degree of that is 1 because it's x to the first power. And then the ones that we're going to be talking about obviously are going to be x squared. Those are quadratics. All right, so we know what a standard form of quadratic is, hopefully, ax squared plus bx plus c. We've been working with those all semester already. So now, hopefully you guys remember how to graph these. If not, I do have videos on my YouTube page about graphing these that you can find, or you can read about it somewhere else. But the standard, or the parent function is y equals x squared. And from your origin, you go over 1 up 1, over 2 up 4, over 3 up 9. And then you can flip those points over because they're symmetrical. So, just a real quick discussion on these. We're not actually going to graph them, we're just going to discuss them. So A just has a stretch factor of 1/3. So we would go from the origin, we go over 1 up 1 times 1/3. Then we go over 2 up 4 times 1/3. Then we go over 3 up 9 times 1/3. And we would flip all those points over. So same thing with B. We would multiply all of our vertical movements by that stretch factor of 2. So now with C, notice you got a negative in front of it. I know people already know this, so you're like, hey, it's open and down. You were exactly right. So instead of going up with our movements, we're going down. Now that +1 on the outside, some of you may not remember that. That is a vertical movement. So instead of starting at the origin, we have to move our graph up 1. So at 0, 1, we put a dot, that's our vertex. And then we start doing our other points by going over 1, down 1, over 2, down 4, over 3, down 9. All right, last one, D. Now, if you really remembered this, you would remember that the value inside, it lies, and the number on the outside tells the truth. So the number on the inside is the x value of your vertex, the number on the outside is the y value. So this one would have a vertex at -2, -3, because the inside value lies. And then from -2, -3, we would use our growth pattern of over 1 up 1, over 2 up 4, over 3 up 9, and plot the points and flip them over. So I hope you guys remember that. And here's just a discussion of that. So you can read through that, but hopefully that got beat into your head during Algebra 2. So a couple different ways we can go about identifying this vertex. At the beginning of the semester, we actually talked about how to find the vertex in standard form, and that was negative b over 2a. Then we would plug that value back in to get our y. But excuse me, we've started talking about completing the square. So I'm going to work this one out by hand, showing you how we can complete the square on this to get it into the graphing form. All right. I have to walk over here, so I might be quieter, but hopefully you can still hear me. So hopefully you guys remember doing completing the square, because we worked with that last week, 2 weeks ago, before the coronavirus pandemic. So I'm going to start off, and I'm just going to go through and explain how to do this. First step is we've got to get rid of that 7. So we're just going to move that 7 to the other side by subtracting it. And that's just for us to kind of get it out of the way, so we don't make any little mistakes with it still being over here, because we don't have to get there now. So now, hopefully you remember that your A value has to be 1 with completing the square. So we're going to have to factor 2 out of everything on the right there. 7. So I'll write down my f of x minus 7 equals, I'm going to factor my 2 out. So I've got x squared plus 4x, and now I'm going to leave my little space there, because we're talking about that too, because we got to come up with our new c value. So we take half of b, then square it. So half of 4 is 2, 2 squared is 4. So that means we have to add 4. So that means we have to do the same thing to the other side, but notice we have this 2 out in front. So we have to multiply the 4 times 2, and we get 8. So really, we need to add 8. So remember, whatever we do to one side of the equation, we have to do to the other. So that gives us f of x plus 1 equals. Now we can factor this. We got our stretch factor of 2. Two numbers that multiply together gives 4, but add up to be 4 is 2 and 2. So it's x plus 2 squared. Last step, subtract 1 from both sides. Now we can easily see the vertex. So what is the vertex? Oh, exactly right. It is -2, -1, because the inside value lies. So that would be where we would start to graph it, and then we would go over 1, up 1 times 2, our stretch factor, over 2, up 4 times 2, our stretch factor, and so on and so forth. And then we flip all those points over. So hopefully that isn't too bad, but that's something we're going to be practicing. All right. So now we've got another problem here about identifying the x-intercepts. And again, if you have a graphing calculator and it crosses nice and neat, we could be using our graphing calculator if we want to. Or, again, we could factor it, or we could do completing the square. Since we've practiced factoring a lot, I'm not going to do that example. I am going to use completing the square to solve this. So, but again, if you want to factor, you factor out that -1, and then just find two numbers that multiply together to give you 8, but add up to be -6. Super easy problem. But I feel like we need to practice completing the square a little bit more. So I'm going to, again, start it off the exact same way. Add 8 to both sides. And I'm going to go ahead and factor out that -1. So I have x squared minus 6x, and I leave me a little space there. So now I take half of 6 squared. So half of 6 is 3, 3 squared is 9. So whatever I do to one side, I got to do the other. But since there's a -1 out in front of that, I got to do 9 times -1. So really I'm subtracting 9 from both sides. So I've got f of x minus 1 equals -x minus 3 squared. All right. So my last step, I have 1 to both sides. We're going to have to do something else with this here too, but I got f of x equals -x minus 3 squared plus 1. So now we can see the vertex of this, but that's not what we were trying to find. So what do you think we should be doing now? Oh, I'm sure somebody out there said it. So if we're trying to find the x-intercepts, we know like our y value is 0. So I'm just going to replace my f of x, because remember that's like y. I'm just going to replace that with a 0, and I'm going to solve this thing. So I'm going to put -x minus 3 squared plus 1. So I'm going to subtract 1 from both sides. Factoring would have definitely been way shorter, maybe all to that at the end. But again, I'm just doing this to practice completing square. Now I need to multiply both sides by -1 to get rid of this guy. So we got 1 equals x minus 3 squared. Now I'm going to take square root of both sides. Take square root of 1, that's going to give us a positive and -1 equals x minus 3. So our last step is to add 3 to both sides. So we have 3 plus and minus 1 equals x. So our two solutions would be 3 minus 1 is 2. 3 plus 1 is 4. So this thing crosses at 2 and 4. Again, the factoring would have been way, way quicker in this situation. But not all the time. So if we were going to factor it, I would squeeze it in over here. The original problem was like y equals -x squared plus 6x. I forgot it. Minus 8. So I factor out a -1, so I can factor these in. And I'd say, well, what two numbers multiply together to give me 8, but add up to be -6? I'd say, oh, that's x minus 2 and x minus 4. Notice the two values that make this 0 is what we got over here. So in this situation, the factoring would have been way quicker. All right, so fun stuff, right? All right, so we want to try to write equation of a parabola and making sure it passes through a given point. So I'm just going to kind of walk you through this and let you practice it and see how we do here. So we think back to what the general form was a couple slides ago. That was a times x minus h squared plus k. So in this problem, this is like h and this is k. That's our vertex. So, and we don't know the a value, all right? But we also know it passes through this point. So I don't have enough room to write there. But in that value, we have a 3 and a negative 6. So the 3 is like our x value, and a negative 6 is the y value. So we can plug all those into this general form, and then we're going to solve it for a so we can figure out what the stretch factor is. So that's what I'm going to do. My y is negative 6. We don't know a, and x value is 3. So h is minus 1, which means that odd number, squared, plus k, which is 2. So we're just going to work this guy out. Negative 6 equals 3 minus 1 is 2, 2 squared is 4. It's like 4a plus 2. So I'm going to subtract 2 from both sides. And then the last step is to divide everything by 4. And we get a equals negative 2. So now we have our stretch factor. So I'm going to come back over here and I'm going to write out our equation. So y equals negative 2 x minus 1 squared plus 2. So that would be our equation. Super easy to find the vertex now because we can see it's a negative 1, positive 2, and it has a stretch factor of negative 2, so it's opening down. All right, well, so with this problem, and again, it kind of makes it hard because I know a lot of you don't have graphic calculators. So I'm just going to kind of talk to you about this problem because you can't get online and go to like use Desmos or some other graphing utility online or whatever you may have at home. So this one is telling us a lot about the baseball's hit 3 feet above the ground and the degree and everything, and then it gives us the path of the ball with a quadratic, and it wants to know what the height of the baseball will be. And where is the height of the baseball and x horizontal distance from home plate? I'm sorry, I'm getting confused here. That's what the x means and y. So what is the maximum height reached by the ball? So all we would do if we want to do this by hand or in the calculator, we just type in the calculator and hit graph and do that second calc max feature. And if you did that, you would get that it's right about 81 feet, 81.125 feet is what I got when I worked that out. But these are some problems that we'll try when we get back to school, just to make sure you remember how to use calculator. You could also do it by hand if you wanted to, by calculating the value of the vertex by doing negative b over 2a. But I would tell you use calculator to do a problem like that.